Hello and welcome to another episode of Growth Unplugged, the podcast where we discuss manufacturing, the future of manufacturing, and unplugged stories. Today I have Jacob Klinginsmith. Jacob here is the president of Tamarack Aerosystems. Jacob, welcome to the show.
Thank you. Appreciate being here. Yeah.
Yeah, where are you based out of, Jacob?
Our headquarters is in Sandpoint, Idaho, up north.
Wow. I'm based out of Dallas. I think we are having better weather today than you.
Absolutely. Yeah. It's snowing like crazy right now, and it's about 15 degrees. So you are having better. I know for sure.
Awesome. To all our listeners, we're going to be talking a lot more today with Jacob, who comes from the aerospace industry. He has a lot of experience there. Jacob, why don't we get started with your background and what led you to Tamarack?
Sure. I have an engineering background. My degree is in mechanical engineering, but I've only ever worked in aerospace. I started my career at what was at the time Quest Aircraft, helping them certify the Kodiak aircraft. I was there for about 5 years and then transitioned over to Tamarack Aerospace, helping with all kinds of engineering efforts, and worked my way up to be chief engineer here at Tamarack. I've been here for about 15 years total, but been president of the company now for about 5 years. Really excited about what Tamarack is doing. I love innovation, and Tamarack is all about innovation and efficiency, which is another passion of mine. Just wearing my engineer hat, finding ways to do more with less effort, with less energy, with less emissions from a sustainability standpoint. So very excited about all the technologies that we've developed here. I was here at the very beginning, essentially a month after our founder created Tamarack Aerospace. So I've been here for the whole journey, which has been exciting.
Can I say you pretty much have been part of a manufacturing startup that has grown on now to become a sustainable large company? Is that a fair assessment?
Absolutely. In fact, in a way too, when I was at Kodiak, that was before they were in production. That was before it was certified. I was there for setting up the production line, that entire process, at least seeing it. My work was on the engineering side. Here at Tamarack, we started as a couple engineers in a hangar, and now we have FAA authorization to produce and install components. So we've started from literally zero and built it into what it is today. I'm very proud of that.
Wonderful. I think that's very interesting, especially for everybody who's listening to this podcast. They're a 15-year-old, 20-year-old thinking of starting a startup in manufacturing. Here's somebody who's been there, done that in the US. I think that's very exciting. Sure. Let's start more from the aerospace industry itself, right? When we did an initial conversation, I think what stood out for me was this whole aspect of sustainability. I don't think a lot of people understand it, but if you were to explain sustainability to your mom, how do you do that?
Aviation by nature is energy intensive, right? It takes a lot of energy to lift an airplane into the sky and keep it there safely for an entire flight. Sustainability is about doing that more efficiently, using less energy, whether that's jet fuel or electricity or hydrogen, whatever the fuel source is, using less of that. What's exciting about our technology is it reduces the drag on the aircraft and helps it climb better. So it's using less energy to perform the same trip, or potentially do a longer trip with the same amount of energy. That's very exciting. The other side of that is on the front end, not using the energy in the first place, but also not emitting as much because you're consuming less, which is the twofold thing. One of the real benefits of what we're doing is it costs less to do the same trip, but you're also emitting less bad things into the atmosphere.
When you speak about efficiency or making it effective, it's not only from the angle of cost, but also from clean energy and from the environment space. Would that be correct?
Exactly. It's less pollution in simple terms, but it's also less energy, so it's less cost, which is very important. If operators are going to be motivated and incentivized to use it, there has to be a cost savings in some way. That's one of the beauties of what we're doing. As a business, you would choose this because it saves you money, but also as a human, a member of society, you would choose it because it has less pollution.
If we could then take 2 steps back, Jacob, that whole aspect of sustainability, and if we just take the aerospace industry, which is like massive, right? It's just not the commercial airlines, just not the defense and aviation space also, with Elon talking so much and promoting it. That's a whole new area. When we connect that to sustainability, What's the biggest challenge today in the aerospace industry?
The biggest challenge is the trending right now. The trending is that people are traveling by air more. The industry is looking at of all the elements of aviation. You're exactly right. That has many different facets. Still, the single biggest consumer of energy in aviation is pretty routine airline travel, what we call narrow body airline travel, whether it's a Boeing 737 or an Airbus A320. Those are by far the most common use of aircraft. That's a foundational trend of how aerospace works right now. Going forward, it's expected that people, economies, will start flying more. That's where there's an opportunity. If we can help those specific kinds of aircraft burn less fuel and be more efficient, then we can have a huge impact on aviation sustainability.
Everything then you do at Tamarack is pretty much all the flying that's happening. If you can make that flying sustainable, that's the value proposition of Tamarack, pretty much to say.
Exactly. Yeah, exactly. An airline using those narrow body aircraft, we can save them about $1 million a year per aircraft, which is significant considering how much those aircraft are used and how common they are. That's a really significant part from a business standpoint. On the emissions standpoint, like I said, the vast majority of emissions are coming from those kinds of aircraft. If we can save 8 to 10% of emissions on those aircraft, that's going to have a huge impact just because they represent such a huge portion of aviation.
In order to do this, ultimately your manufacturing or some product basically has to come in which does this. Tell us a little about what that product is. How does that product work and what is it called?
Just going back to first principles of airplanes and how they work, we all have an intuition or expectation that a glider is the most efficient kind of flying. It has no motor, so it has to be very low drag, very efficient with the way that it lifts the aircraft. We can make aircraft a little more like a glider by extending the wingspan, essentially. In the past, businesses have done this, companies have done this with what is called a winglet, a vertical fin at the tip of the wing, effectively increasing the wingspan and reducing the drag on the aircraft. In the past, when that's done, there's a limit because as you extend the wingspan, the wing is carrying more bending moment. The load on the wing is moving outboard, so it's higher stress for the wing itself. The key to our technology and what we're excited about is going to that next step is we're adding a system. We're going to expand the span, which would increase the stresses normally, but we're putting a system in there to counteract those higher stresses only when the wing is experiencing those higher stresses. It's an analogy we like here because it's snowing out. We could build a building that could withstand a lot of snow with a really strong roof, or we could just put a heater in the roof and melt the snow when the snow comes. Then we don't have to have as much structure in the building. That's not important. The structural weight isn't important for a building. In the airplane, it really is. That's how we're handling those increased loads. That's how we're able to do more than what has been done for many years to increase efficiency effectively, just from first principles. We're taking it to the next step by combining those elements to get a much bigger benefit.
The winglet is ultimately, with all the stresses, etc., in the air, traditionally what you're saying is that it is constantly trying to address that. In the air, what you're saying is that it may not always be the case and may always not be needed. The system that Tamarack produces, the analogy I was thinking when you were talking was more like AI in the air, right? It's learning, hey, when do I need to do my job and when I don't need to do it? That way I will only consume the fuel that I need when I need to do the work. Would that be a good analogy too?
Exactly. It's adapting to the flight condition. The wing is physically moving and adapting to the flight condition so that it doesn't overstress. In normal flight, when you're just cruising in flight, then you're getting all of these aerodynamic benefits of being a little more like a glider, having less drag. Yeah, that's a great analogy.
Talk about it a little more from the innovation standpoint, right? I can imagine in this mind that if I was telling this to my son and he visually saw it and he would say, what's the big difference? It's just going up, down, left, right, or something, right? How can it be so difficult? But I know it is complex. What are the variables or what are the aspects that you really need to take into account which makes this space such a great area for innovation, Jacob?
One element that makes it high tech is that when you're flying, the reaction, the adapting in the air has to happen very fast. As you could imagine in turbulence, which is stressing the wing, for example, all of that's happening very fast. So The system that's monitoring and doing the work has to be really rapid. If you think about like the airbag in your car, that system has to be in position very quickly in about a tenth of a second. It's very similar with our system and our technology. It has to be able to adapt to the conditions very quickly. It's about a tenth of a second that we have to be able to be in position with what the wing is doing so that it doesn't experience an overstress. That's one of the technical and exciting parts about what we're doing. The other part is just extending the wing, and that part is a little bit simple. It goes back to first principles of making it more like a glider. Looking at it sitting on the ramp, you say, oh, it's just a longer wing, but it makes a big difference. We're looking at the results, not just the technology.
Would it be fair to say that if this was done multiple years ago, the larger aspect was more mechanical in nature? Now, with technology coming in, it's just not mechanical, but it's also different streams of engineering that are coming together. If it is, how complex is the system becoming? You also need the innovation of just bringing everything together.
Sure. One thing, just like any other element of technology, as different components and different things become smaller and lighter and faster, it opens up new possibilities. So we always say we didn't invent this active load alleviation that's actually been around a long time. We didn't invent winglets. Those have literally been around for 100 years, but we're putting them together. The timing was right to be able to see the opportunity in the technology and the downsides of historical winglets, what we call passive winglets. Those historical winglets have required just physical, metal, heavy reinforcement to be able to do as much as they could. There's these trade-offs. If you put too much metal in, you can't take as many passengers, so it's not as good of a benefit. So that trading and finding the sweet spot, what we're doing is basically shifting that sweet spot using a system so that we can do more aerodynamically, get a bigger benefit aerodynamically, but not have those heavy structural penalties that were associated with older technologies. So it's neat.
So I heard there's physics, there's basically metals, which is more chemistry coming into picture. There's more mechanical, the way you machine it, etc. There's software, obviously, that I heard in that. Is there anything else that I'm missing here apart from those that also is a part of the science here?
No, I think you got everything. As far as physical hardware, the other thing that maybe isn't obvious is some of the materials. There's metals, but there's also carbon fiber. That's one of the neat technologies that has come a long ways in the last several years.
Is that the same thing as composites?
It is. That's a specific kind of composite.
Yeah. I think what I missed might be is electronics. Is there a lot of electronics that has to come in here? When we see airplanes, the cockpit largely, there's just a lot of electronics. Would there be that much electronics here?
Yes, it's not electronics that require the pilot to have a lot of input. Just because the nature of the system and the way things have to happen so quickly, it has to be automatic. Of course, there's a way for the pilot to monitor and check the system before flight. In flight, it's all automatic. That electronics is there, it's in the background. But again, going back to the airbag analogy, it's there. And if it's not working, there's a light on that tells you it's not working. Other than that, they're doing its job without the driver being involved.
Gotcha. I think for all our listeners who've been listening to this cast so far, especially if you're a 15 or a 20-year-old, I think this was a good crash course that Jacob gave in terms of how a winglet is made and what are all the different sciences that go into making Tamarack systems work. Thanks for those insights. If we take a segue into the future of manufacturing, I want to actually start more from a career question, right? Young people joining just manufacturing in general, but aerospace. I remember in the US, the 1960s or 50s, when we had to go to the moon. It was like a world event, right? Everybody wanted to join the aerospace industry. Over time, it's changed and it's got complex. What do you see? Is there a challenge to attract young people to the aerospace industry? Or are you seeing the opposite where more and more young people are joining the aerospace industry?
It's a little bit mixed. If we look at the aerospace industry in the biggest picture, there's a lot going on with space right now. SpaceX and Blue Origin and the incredibly innovative things that those companies are doing, which is going to change humanity in a big way. That's very exciting. That's attracting a lot of young talent for that. In more traditional aerospace industry, there's a very big push having to do with sustainability and mobility as far as urban air mobility. Those are two areas that are attracting a lot of young talent with people with a big passion for making aviation more sustainable looking forward, whether that's hydrogen propulsion, electric propulsion, things like we are doing, making existing airframes more efficient. There's a lot of room for innovation. We all know that airplanes have basically looked the same for a long time. There are people looking at completely different designs that are more efficient. They come with their own challenges. If we reevaluate, now we have new technology that maybe changes the way we should be doing it. There is a lot of innovation coming together right now that is attracting talent, which is good.
I see a lot of startups on LinkedIn and elsewhere who are pretty much building new kinds of planes which have like a vertical takeoff. I saw Uber plane or Uber air taxi or something like that. A simple question or a silly question is, do winglets have applications even there too?
Sure. Yeah, air taxis as an umbrella term come in all shapes and sizes. There are many companies working on those. The ones that tend to look a little more like an airplane with a fixed wing that fly on a wing, there's definitely opportunity for our technology for helping them climb better and be more efficient in flight. Our technology certainly could be applied there.
What attracted you? If you had to go back 15, 20 years when you started off, you were the young guy, somebody who's listening to this podcast, they would pretty much be stepping into your shoes many years ago. What attracted you to this industry, Jacob?
How do I say it? It's very technical. It wasn't an easy problem. I had actually expected to go into a different industry that was more simple. When I started looking at what goes into designing airplanes and testing airplanes and coming up with new technologies, that was attractive to me because it wasn't just doing the same thing. We go to the book and we look up the table and we do the design based on that. It's starting from scratch. We don't know how to do this. We're going to do a test and see if it works. If it doesn't, we'll make it stronger. We'll change it. That attracted me to what's going on in aviation in general. Flight is such a fascinating thing. Even those of us who are in the industry are just constantly amazed that we can make these machines that fly and do all kinds of things. Now we're seeing spacecraft go to space and come back and get caught on chopsticks. All of that is just very exciting.
I was showing that to my son. He's 9 years old and he's, what's the big deal about that? I said, oh, it is a big deal.
I had the same response from my kids.
I think that shows our passion, right? I don't know what's the lingo that is going on in Gen Alpha generation. What's the latest called? I call myself as the millennial generation. For us, that whole video of it being caught back, or just the fact that so many things, when I just saw even the air taxis, we used to watch the Jetsons cartoon. Everything is just coming to life. I'm waiting for the day where we are able to put the kind of a helmet that Jetson used to put it, and then our hair automatically gets cut. I still want that to happen, but I think way cooler things are happening. That technology, whether it's robots, AI, automation, and just new tech or high tech, tell me a little bit from your experience right now. I know that it's changing the design side, like we are really able to come up with new products. But is it also changing the factory and the manufacturing side of it?
No, it definitely is. Of course, if you look at things like the automotive industry, where it's high production, automotive has been using robots for a long time. On the manufacturing side, aviation has been, I would say, lagging in a lot of areas, mostly because of heavy regulation. If it's approved to do a certain way, then we don't want to change that because that's already approved and it can be done that way. As technology advances and things get better with technology, it's time to reevaluate that. There are opportunities and things coming along. I met last week with a company that's doing composites that are 3D printed, and it works really well for commercial applications, but they're working on getting it approved for aviation, which is a very difficult task. This is a good time to reevaluate. Maybe it can be done better, more efficiently with today's technologies. There are big changes happening, but aviation in particular has a lot of historical things because of the regulation. There's a real challenge to that. Some young person looking for a good challenge would do well to get into aviation and bring some of that technology that really is going to help humanity and help the industry, bring that forward and work with the authorities to have it approved, to prove that it's safer and more efficient in all those ways.
You just opened a huge area. I was never thinking that that could be a scope for youngsters to get jobs, right? I think there's a whole parallel pathway here where just working with the regulatory authorities to take away regulation, to say, hey, this is redundant, you no more need it because The tech has just solved it where you don't need to be worried about this. How do you take care of this in reality where you see there is regulation, you see an opportunity for you to be yourself to be efficient, whether it's on the design side or manufacturing? Is there a process that you have to follow, or you just have to do with compliance?
There's certainly compliance that's required. In the more general aviation sector, the structure of the regulations is changing. There are more avenues to say, yes, we've done it this way forever, but here's a new way and it's better. Very methodically, we can prove that it's better. That is a way, and still be compliant. There is a way there, especially in smaller aviation. That's where the innovation comes, and then that feeds into the bigger aviation after it's proven in a smaller setting. So there's definitely opportunity there.
Got it. When I talk to a lot of youngsters, whether it's in STEM programs or just people who work for me, and I'm sure you're also seeing the world around us on Instagram, etc. There's a lot of leaning towards data when it comes to innovation and the new tech. If we talk about ChatGPT, it's talking about how to take so much data and then make sense of it. Where is data and decision making in aerospace, Jacob, in your experience?
That's a broad topic. I love innovation and I love doing things better and faster and less expensive. I see a huge opportunity, and that's something Tamarack is very focused on. We are not only a product company and a technology company, but an engineering company. Something that our engineering team is looking very seriously at is how do we use these new tools like artificial intelligence and even ChatGPT to be able to do even better work faster and come up with, more efficient designs. That's a really broad topic, but I think there's a huge opportunity. Some people are worried about AI taking away their jobs and things like that. I don't see it that way at all. We used to wash our dishes by hand, and now we put them in the dishwasher. We get to go do something else that's more productive or that we would enjoy more because the dishwasher is washing the dishes. I see it the same way. I don't think it's taking jobs. I think it's making us more capable than we were before. We need to embrace that and find ways to make the most of it.
I see the AI revolution pretty much more like the initial computer revolution when we were moving from paper to calculator to the actual computer, the kind of resistance that we had. Mm-hmm. I think I'm seeing that kind of resistance today on the AI side, but you're very right. Let's break that down if it is a broad topic, right? Does aerospace manufacturing really involve huge amounts of data today?
One of the things that is required for showing compliance is data to back it up, especially if we're talking about materials, whether that's metal or composites, requires testing. A lot of that is in process. Something that may not be obvious is in aerospace, everything that goes onto an airplane that's going to fly has to be traceable back to the dirt it was made out of. There's a lot of data behind that piece of airplane. Managing that data is a huge opportunity to be streamlined. A lot of times that's printed in the industry that's set in its ways. The joke in aviation is the paperwork has to weigh more than the part. That's too true. Of course, a lot of things are coming along in that world, but there's still a lot of room for improvement. That's just on the manufacturing side. Already, companies are adopting electronic databases and ERP systems. There's always room for improvement, and there's always room for finding efficiencies that are not obvious, especially in a bigger organization. Technologies can help us with streamlining that process.
Do you see the industry moving more towards taking decisions using data? Is that something that you see happening less today, or a lot of data is used for decision making?
I think as far as the certification side, it's very data rich. In a bigger manufacturing organization, it's very data rich. Just looking at composites, when we produce a composite part, of course, the materials are traceable, like I was talking about, but then also every step of that material's life is tracked, including the temperature and humidity of the environment that it's stored in, how it's cured in the oven, and not only what was it at a certain point in time, but continuously, what is the temperature? It's very data driven from that standpoint. There are definitely ways to streamline that as we look at new technologies.
Got it. If a 20-year-old was listening to this, Jacob, what would be your advice for him to get into the industry space today?
That's a good question. It's relevant. So I have a daughter. She's 17. So that's not too far off. So It's easy for me to think about.
I'll rephrase the question. What would you tell a 17-year-old?
What I'm telling my daughter is to try it out. Get a job, be in the environment, see what's going on. From a business standpoint, see how things are being managed. From a technical standpoint, try it out. As somebody under 30, you have lots of time to go try something for a couple of years and really know if you like it or not. If you're in a bigger organization, there's room to possibly to move around and try different things. As a 17-year-old, a 20-year-old, you may know exactly what you want to do, and that is awesome. Usually people don't, including me. I didn't know it when I was 17 to 20. Just trying some different things and seeing what it's like. The other thing I tell my daughter, a degree is good, but not a requirement. There are a lot of jobs in manufacturing that don't require a degree, that you can be very successful and very fulfilled, especially as AI and other things come online. People that can do things physically with their hands and use good judgment and make good decisions, that's going to be in high demand, because that's one important piece that always has to happen. That's what I'm telling my daughter.
That's awesome. At my company, we took away the real need for a particular degree or anything a couple of years ago with the same philosophy. As long as they could demonstrate the skills, that's a good starting point. And then it's pretty much up to their experience and what they learn to grow. I sometimes think that 17-year-olds, 20-year-old, when they talk to me, many times are struggling to say, hey, what should I learn or set myself up for success? Let's say they were to come and interview at Tamarack, etc. I think the simple things common to all industry, whether it's communication or time management or organization, I think that's where the new generation pretty much has their own mindset, their own language, and their own pace. But I'm asking that apart from the soft skills, sometimes I feel that if they could do something on the technical science side, I think they would be a better bet for the aerospace industry. What comes to your mind, some of the things that you could advise a youngster listening to this podcast that they should look into?
Sure. I can tell you as an employer, what we're always looking for with somebody looking for a job is not only what is your work experience, but also what are you doing outside of work. If you come to us and you want to work in our engineering department, we look for, okay, tell us about a project that you did on your own. You built some widget, or you are into woodworking, or you are learning to fly, something like that. Those extracurricular activities where you're following your passion, if your passion is overlapping with your job, that's a perfect fit.
Yeah.
If your passion is art and you want to come do something very technical for us, maybe that's not a good fit. If you're not doing engineering kind of things outside of work and you want to be an engineer, that might not be the best fit. So we're always looking for, especially in aviation and engineering, looking at people that have a demonstrated passion for aviation in some way. It's not a hard and fast rule, but that's a strong indication of, is this going to be a good fit? It has to be a good fit for the company, but also a good fit for you. You don't want to be here and be doing a job that you wish you were somewhere else. That's not a good life to live. I think that resonates with everybody across the industries, whether that's finance or marketing or engineering or whatever. Your passions have to overlap with your job, or you're just going to be miserable.
Moving to a thought where I call this last piece of the episode more like spilling the beans or spilling the tea. What do you think, Jacob, as one of the leaders in aerospace? Do you think sustainability in aerospace will be driven by regulation or innovation?
It's going to be both. But I like to follow the rule of thumb that humans are always going to act according to human nature, which is in their own interest. I think it has to be innovation like ours, where it creates sustainable benefits, but it also has an economic reward. Authorities could come in and create that economic reward, and they have in some ways. But the ones that are really going to succeed is the long-term economic reward along with the benefits for society. It's going to be both, but I think it's going to be skewed towards the innovation side.
Gotcha. From a manufacturing sustainability standpoint, if you see the future that is and the industry shaping in aerospace, what is the biggest trend that you see for sustainability improving in aerospace in the next 5 to 10 years, Jacob?
Within aviation industry, I think finding efficiencies in the manufacturing side with robotics. That's one area that even the bigger companies, the Boeings and Gulfstreams of the world, they are using robots, but it's still a lot of manual work, looking especially at the manufacturers below that. I think finding ways to automate that and finding efficiencies there is probably going to be an area of focus. Like I said, automotive has been using almost completely automated production lines for a long time. It's different in aviation because the volumes are very different than automotive, as an example. But I think that's definitely an area for improvement. That's got to be the biggest one to me.
Got it. One of the things as a trend basically in the aerospace, apart from the robots, I think you mentioned earlier that the digital tools are being adopted. But I think if the aerospace industry finds a way to be a little more agile in decision making, that could lead to significant cost efficiencies that today we are not able to get. I think that is still like a larger unlock on the aerospace side. At least in my line of work, I'm seeing even that getting added. We were just talking to somebody who's starting up in the aerospace, and they said, we don't know. I asked them, how are you going to set up your factory? We don't know. Sometimes our customers will tell us to stock 1,000 parts and keep it ready. Sometimes they may just ask for one, and we should be able to deliver. We should still figure out to see how we could be profitable. I think the whole manufacturing dynamics is a big area that I'm seeing. How does this translate, Jacob, to you personally? I know your passion has already been driving you so far for the 15 years, and we can see that from the growth that you've had at Tamarack, from the ground up to being the president. What drives you next? I'm always curious to know that you're already a leader. What will drive you to innovate in this space?
The innovation itself, looking for the next technology that's going to help. That's part of the culture at Tamarack. We have close to 30 patents globally. That's not just the products that we're producing today, that's the products that are in the future for us. Mm-hmm. Continuing to find that and continuing to find the tools. That's the sort of the end result internally. I was talking about using artificial intelligence to do the engineering portion better, to create a better product overall, faster, cheaper, safer, lighter, all of those kind of elements that come in, especially in aviation. To me, that's important. Working with younger people is important to me too. That's been part of our core at Tamarack for a long time. We've always had interns in the summer, helping them and teaching them, having a time set aside where all the interns, we're going to learn to weld today. If you've never welded, let's go weld. We'll show you how to do it. After hours, you can use the welding machine and make projects and all kinds of other tools like that. To me, that's an important piece of it. Of course, I already mentioned my oldest is 17, so it's relevant for me with my 3 kids, helping inspire them and the younger people to find their place in work where they're happy, like I was saying, where you're not counting the days to the weekend. That is such a miserable life to live that. Helping people find that place where they can work every day and be happy to come to work. To me, that's important. That's inspiring.
So I think talking about young people, I also want to go into the young professionals that are already working in the aerospace industry today. I see that suddenly there seems to be like a disruption with AI coming in and just technology. There's an overload with the internet. There's an overload in information. I also see that sometimes the skills upgrades that youngsters or young professionals are thinking about is very unidirectional. To give you an example, somebody in the past who was a very good welder, they could probably survive for the next 30 years being the greatest welder in and around the Idaho city. I don't think they could do that anymore. Going forward, we live in a world basically of cross-functional competencies. What would be some of the final takeaways that you could give young professionals, even industry leaders? I see this problem even with industry leaders. I'm fascinated when I was looking at your profile and talking to you. There's so many things that you've touched, but we don't see that across the industry. Any takeaways from your experience that you can share that would appeal to younger professionals and industry leaders that they should be doing today?
I don't feel like there's one answer to that. My personality and my curiosities are maybe a little more broad than some people. There are some people who are passionate about one thing and one thing only. I think you need to follow that to be happy in life. As a professional, I guess that goes that way too. There are some engineers, for example, who are really happy just engineering all day long, every day. They come to work and they're just energized by that. Other engineers aren't as happy with that. It goes across other disciplines too, marketing or whatever. If you're into marketing and you're into videography and that's your passion, and you're going to be the best videographer and editor ever, that's good. You should do that. But you should also look at the new tools and stay on top of that so that you can be the best in your field. If you aren't, you're going to get left behind. That goes across whether you're engineering or marketing or finance. If you're in finance and you're just passionate about bookkeeping, there are a lot of technologies there that you can be using. It really goes across to look at what is the best way to do the job and be the best you can with the tools that are available. If you're resisting that, you're going to get left in the dust, and it happens to people. You have to be ready to adapt and learn and be the best you can be.
You nailed the example. It's a best analogy. That finance, bookkeeping, the way it was manually done, but today you have tools where it allows you automatically any redundant item. Like let's say, if you're paying your credit cards every month, You can just automate that. Now you can use that time to say, hey, how do I learn more of financial decision making? I think that analogy serves very well even for an engineer who's trying to be a subject matter expert. Go back to that welding example. If you're starting to learn welding, I think there are multiple types. Modern welding basically has a lot of technology associated with it. If you're the best, then you should know even that. I think that's a very good insight, Jacob, from that experience that you have. To come to the end of the show, where can people learn more about Tamarack and your work, Jacob?
We're on most of the channels. Of course, we have a website, tamarackaero.com. We have a lot of information there. We have a course that you can take for free on our website that just is a good foundational understanding of what our product is and what the benefits are, the science behind that, and the practical sides of flying with it. We also have a ton of content on the web, on YouTube, especially for young people. One of our more popular series that we've done on YouTube is called Tamarack Teaches. It's short 2 minutes about different aerospace engineering topics. That's been very popular with sort of high school and college age people. That's a good one to check out. Of course, we're on all the social media channels also.
We come to the end of the show. I'd like to tell all our listeners that if you're thinking on the aerospace industry, then Jacob's insights tell one thing very clearly. You need to be innovative and you need to try and build something yourself that is going to develop a good amount of engineering and problem-solving skills that can lead you to success and get started in the aerospace industry. Thank you so much, Jacob, for joining us. It was great to have you on the show.
Thanks for having me.